Hello everybody. Today we are going to learn how to download this book, Thomas's Calculus, and work through the problems in limits. The way to do it is you can search online for Thomas's Calculus book and use the word download in your search so that you find places where you can download. This is one place you can download, and then turn to chapter 2. Go to chapter 2. These page numbers might vary from version to version. So if you go to chapter 2, this would be chapter 2. Let's do one of the first problems. The question is, find the limit as x tends to c of this function x squared x cubed plus 4x squared minus 3. So let's do this problem. So what we do here is we substitute x equals c to this problem. Before that, we will use the sum and difference rules to write this equation as limit x tends to c x to the power cube plus limit x tends to c 4x squared minus 3. We can say limit x tends to c. So we wrote the same equation using the sum and difference rules of limits. So here what we do next is substitute c to x. So we have c cubed plus 4c squared minus 3. There is no x term to substitute 3. So we have, this is the answer, c cubed plus 4c squared minus 3. Let's go to the next question. So here they want us to find the limit at x equals 1. So if you look at this function at x equals 1, we say x equals 1, the denominator is 0. The denominator is 0. Numerator has a value, but the denominator is 0. So when the denominator is 0, the function is not defined at x equals 1. So you see that function is not defined at x equals 1. But does the limit exist? So if you look at the limit from the left-hand side, it tends to 2. From the right-hand side, it tends to 2 as well. So the limit exists, which is equal to 2, but the function does not exist at 2. For example, here, if you take a look at this function is defined at x equal to 1 as 1. And all other places, it's defined as the same function here. So if you look at the limit as it tends to 1 is 2. From the left side and the right side, it's 2. So here the limit is 2 as well. And in this is quite clear. The limit is as x tends to 1, limit is 2. So in all three of these functions, the limit as x tends to 1 is 2. But let's look and see whether we can mathematically prove this. So we have the same function and we have to see the behavior at x equals 1. The problem here, as I mentioned earlier, was when x is equal to 1, the denominator is 0. So how do we calculate it when the denominator is 0? What we do is we take the numerator and factorize it. So we have x squared minus 1. This can be written as x squared minus 1 squared because 1 squared is 1. Once we have this, we can factorize it as x minus 1, x plus 1. We can factorize it. We'll see whether this is true. We'll use a different color here. It is x squared plus x plus x. Then we have minus x and they have 1. We have 1. Sorry, minus 1. So we have x squared minus 1. So that is correct. So these are the factors of x squared minus 1. If we generalize this, we can also use this function as, if there is a function where you can write it as x squared minus a squared, it can be factorized. Any function, if you can write it as x squared minus a squared, a could be 5, a could be 3, anything. You could factorize it as x minus a, x plus a. Give you another example. If it's x squared minus 9, it could be written as x squared minus 3 squared. So it could be factorized as x minus 3, x plus 3. So here we'll come back to this place and then we'll write this, the numerator, as a factor of x minus 1 times x plus 1 divided by x minus 1. Now we see there is a common factor that we can eliminate. So we cross off the common factors, then we have limit. We should always put the limit. X tends to 1, limit. Let's erase this negative sign, the equal sign. X tends to 1 is equal to, I should get rid of this, is equal to x plus 1 and we get 2 here. So this is correct because that's what we showed here, that as x tends to 1 from the left and right we get a 2 and it is mathematically proven now. Next, let's look at this question. So we have x cubed plus 4x squared minus 3. And in the denominator we have x squared plus 5. Let's look at the denominator. And if we substitute minus 1, we have here minus 1 squared plus 5, which is 4. Which is 6. And it's not 0. The denominator is not 0. So we can directly substitute x equals 1 to this equation. So we get minus 1 cubed plus 4 minus 1 squared minus 3 over minus 1 squared plus 5. So now I'll have a small note here. We have to remember that 1 minus 1 times to the power 3 is equal to minus 1 times minus 1 times minus 1 is equal to minus 1. Minus 1 squared is equal to minus 1 times minus 1 is equal to 1. So if we substitute it back, we see that this is minus 1 plus 4 minus 3 over 6. And we get 0 here. So 0 over any number is equal to 0. The other way around, if it's any number over 0, this is not defined. So the answer here is 0. Let's go and do the next. So the next question is, limit as x tends to 5, what is x minus 5, x to the power square over x to the power square minus 25. First thing we do, as mentioned previously, is we look at the denominator. Denominator, as you substitute x equals 5, it's 25 minus 25 is equal to 0 in the denominator. So it's not defined. The function is not defined at x equals 5. But we want to calculate the limit of at x equals 5. So here we need to factorize the denominator and make sure we can substitute x equals 5 without this turning into a 0. So let's look at the denominator. We have x squared minus 25. This is similar to x squared minus 5 squared. So previously we learned that x squared minus 5 squared could be written as x minus 5, x plus 5. This was similar to the example I did previously where it was x squared minus a squared can be written as x minus a, x plus a. Let's see whether this is true. We multiply this by this, x squared, then by this, plus 5x minus 5x plus minus 25. So this is equal to x squared minus 25. So because this would give you minus 25. So we'll bring it back here and substitute the factors. So we say limit x tends to 5, x minus 5 over x minus 5 times x plus 5. So we cross off the common factors and we have limit as x tends to 5, 1 over x plus 5, which is equal to 1 over 10. That's the answer for the limit of this function as x tends to 5. So let's do the next. In this question, we do the same thing. We substitute x equals 5 to the denominator. X equals minus 5 because the function as limit goes to minus 5. When you substitute minus 5 plus 5, we see that the denominator is 0. So the function is not defined at x equals minus 5. But in order to find the limit, we need to make sure we factorize the numerator and cross off x plus 5 so that we can get a true value. So let's look at the numerator. So we have x squared plus 3x minus 10. So we will try to factorize this. So 10 can be written as, as 5 times 2 or 5 times 2 is negative. So one of these has to be negative. It could be negative 5 plus 2 or 5 times 2 where 2 is negative. And when you're factorizing, so these are factors of 10. There's another factor of 10 we can use is 10 times 1. 1 times 10. And one of these has to be negative so that you get negative 10. So that's how you can make negative 10. But when you're using factorization, you need to consider the second term as well. Here, if you take 5 times 2 minus 2, and you add the 5 and minus 2, you get 3. For example, we'll add these two. If you add these two, you get minus 3. If you add these two, you get plus 3. So this is the correct term to use when you're factorizing, because when you multiply, you get minus 10. When you add these factors, you get plus 3. So that is the correct the value we need. Let me put that in different colors. So this is what we need. So we take these two values and write the factors as x plus 5, x minus 2. And when we do that, we'll start multiplying. We get x squared and we multiply by this, then it is minus 2x. Then we do this plus 5x and then we do minus 10. So we get x squared plus 3x minus 10. So it is equal to this. That confirms that this is the that these are correct factors of this equation. So let's write it here. So limit as x tends to minus 5, we have x plus 5, x minus 2 over x plus 5. Now we see we have a common factor. We cross off the common factors and then we have x minus 2. So we have x minus 2 here. So we do limit as x tends to minus 5, x minus 2. This means substitute minus 5 to this and we get minus 7. That's the answer. Let's go to the next question. The next question is limit as t tends to 1. It doesn't have to be x, it could be any variable. Here the variable is t. As t tends to 1. Let's see what happens to the denominator. As t tends to 1, the denominator is 1 squared minus 1, which is equal to 0. So the function is not defined at t equals 1 because the denominator is 0. So now what we need to do is, though the function is not defined, we have seen that we can still find the limit. To find the limit, we have to factorize this. So let's see whether we could factorize this. We know that, let's just take the denominator. We know that t squared minus 1 is a form of t squared minus 1 squared. So we can write this as t minus 1, t plus 1. So we have factorized the denominator. Let's look at the numerator next. Numerator is t squared plus t minus 2. So minus 2 can be written as minus 2 times 1 or 1 times minus 2. Now we want to be able to, the middle term should be the addition of this. If you look at the addition of this, this would give an addition. If you add minus 2 plus 1, you get minus 1. But here, sorry, it should be minus here, plus here. Because one of these terms should be minus so that you'll get a minus term here. So minus 2 times 1 is minus 2. Minus 1 times 2 is minus 2. But when you add these two terms, you get a plus 1. Plus 2 minus 1 is plus 1. So if we factorize this as t minus 1, t plus 2, we see that we'll multiply them. T squared plus 2t minus t minus 2. So you do get t squared plus t minus 2. So this would be the correct factor we need to use in the factorization. So we have it here. So we will substitute this to the numerator, this is the denominator, and see. So limit as t tends to 1, we substitute t minus 1, t plus 2, that's the numerator. Denominator is t minus 1, t plus 1. So now we see that there are common terms we can cross off. We cross off those common terms and we have limit t tends to 1 as t plus 2 over t plus 1. The answer would be 3 over 2. As t goes to 1, you substitute t here. We'll go to the next question. In this question, as limit of x tends to minus 2, let's look at the denominator again. So we have, in the denominator, we have minus 2 to the power 3 plus 2 times minus 2 to the power 2. So here minus 2 to the power 3 is minus 2 times minus 2 times minus 2 is equal to minus 8 plus 2 to the power 2 here is 2 times 4. So it's minus 8 plus 8 makes it 0. So the denominator is 0. The numerator has a number, denominator is 0. And this is not defined at x equals minus 1. So as x equals minus 2 is not defined. As it's not defined, what we do here is we take the common factors out. We just take the common factors out here. So we say limit x tends to minus 2. We take minus 2 out. That's a common factor. We get x plus 2 in the numerator. And then we take x squared as a common factor. When you take x squared, we get x plus 2. Now we say we see that we can cross these off. So we will cross the common factors out. Then we are left with limit x as it tends to minus 2, and we have minus 2 over x squared. So what we do here is we know that the denominator is not equal to 0, and we can substitute x equals minus 2. The denominator will not be 0. So once we substitute that, we get minus 2 over 4, which is equal to minus half. Let's do the next question. In this question, we will calculate the function as x tends to limit as we have to calculate the limit as x tends to minus 3. So first let's look at the denominator. If you look at the denominator at x equals 3, we see it's minus 3. Sorry, x equals minus 3 because that's where the limit is. X equals minus 3 squared plus 4 times minus 3 plus 3. So we have here this minus 3 times minus 3 is equal to 9 minus because 4 times 3 minus 3 is minus 12 plus 3. So denominator is equal to 0. So function is not defined at x equals minus 3. But we are looking at finding the limit as x tends to minus 3. So let's factorize the denominator because there is nothing to do in the numerator. We can't factorize or bring any common terms out. So let's look at the denominator. So we will write it as x squared plus 4x plus 3. So 3 can be written as, what are the factors of 3? 3 times 1, that's all, 3 times 1. And we know when you add 3 and 1 together, we get the middle function. So this can be written as x plus 3, x plus 1. Let's see whether this is correct. Is equal to x squared. And when you multiply this by this, plus x, then here plus 3x plus 3. So this is x squared plus 4x plus 3. That's your function. So these are factors. This is correct. This is the same as this. So these are the factors of this function. So let's write it down here. Limit as x tends to 3, x plus 3 over x plus 3, x plus 1. And we see some common factors here. We cross off the common factors and then we get limit, sorry, this should be negative, x as x tends to negative 3, it is equal to 1 over x plus 1, which is equal to 1 over 2 negative. That's the answer. Let's go to the next question. The next question is x limit of as x tends to 0, x tends to 2, the limit of this function as x tends to 2. Let's look at the numerator again. As x tends to 2, we look at the numerator, it's 2 minus 2. We substitute 2 here. It's 0 in the denominator, so it is not defined. So here what we can do is take the numerator and factorize it. So we have x squared minus 7x plus 10. So let's factorize 10 so that we get a 7 when you add the two numbers. So 10 can be written as 10 times 1 or 1 times 10 or 5 times 2. And if they are both negative, you get minus 5 times minus 2 is 10. That's correct. And minus 5 plus minus 2 is minus 7. So the middle term is satisfied and the final term, third term is satisfied as well. So let's write the function as factors x minus 5, x minus 2. And let's multiply them now to see whether this is correct. X squared minus 2x minus 5x plus 10. Minus 5 times minus 2 is plus 10. So we get x squared minus 7x plus 10, which is the same function. So these are correct proper factors of this function. So let's substitute it here. Limit as x tends to 2, x minus 2, and here we'll substitute x minus 5 to the numerator, x minus 2. This is where I have copied it from. Now we know, we see common factors. We'll cross off the common factors, cancel the common factors off, and then we see we have 2 limit x tends to 2 of function x minus 5. So when you substitute 2 here, we get minus 3. Let's look at one question. We do the same thing here. The function is to calculate the limit of this function as t tends to minus 1. Let's look at the denominator first. As t tends to minus 1, let's substitute minus 1 to the denominator, squared minus minus 1 minus 2. So we get here only the denominator. We get 1 plus 1 minus 2, which is equal to 0. So the function is not defined at t equals minus 1, but it still has a limit. Let's look at the value of the limit. The way to do this is we will have to, there are no common factors we could take out, so we'll have to factorize it. Let me look at the numerator first. The numerator is t squared plus 3t plus 2. So 2 can be written as factors, 2 times 1 plus 2 plus 1. If you write that as factors, we will see you'll see 2, should be t plus 1, 2 and t plus 1. Let's see whether this is correct. It's t squared plus t. You multiply those two, you get plus 2t. You multiply this, you get plus 2. So we get t squared plus 3t plus 2. Yes, you get the same value function back. So these are proper factors. Let's look at the denominator now. Denominator, we will use a different color for the denominator. So denominator is t squared minus t minus 2. And we will factorize 2. Minus 2 can be written as minus 2 times 1 or 1 times minus 1 times 2. They both give a value of minus 2. Out of these, this one, when you add minus 2 and 1, you get minus 1, which is the middle factor here. So the factors here are t minus 2 and t plus 1. And let's see whether this is correct by multiplying it. We have t squared and plus t. Then here we have minus 2t and this is minus 2. So we do get the function back, t squared minus t plus 2. So we'll substitute this to the numerator and this to the denominator, and we will see this limit t tends to minus 1. The numerator would have, this is the function for the numerator, plus 2t plus 1, and denominator would be t minus 2 and t plus 1. So here we can cancel out the common factors. So we see that they are cancelled out. And then when we substitute, we say limit t tends to minus 1, t plus 2 over t minus 2. We would get When you substitute t equals minus 1, you get minus 1 plus 2, and here minus 1 minus 2. So we would get plus 1 over minus 3, which is minus 1 over 3. That's the answer. As t tends to minus 1, the limit of this function is minus 1/3. Let's look at the next question. The next question, we see we want to find the limit at y equals 0. If you look at the denominator at y equals 0, it's 0 minus 0. So function is not defined. The denominator is 0. So here we need to, first thing we always have done is to see whether there are any common factors. So there are some common factors, namely y squared. So we take the common factors out. So we'll write this again as limit y tends to 0. We take the common factors, which is y squared. So we have 5y plus 8. And again here we have y squared. When we take it out, we have 3y squared minus 16. And we'll cross off the common factors. And then now if we substitute y equals 0, we see that the denominator is not 0. So it is possible to do that. So let's do just that. We'll substitute y equals 0. Then we get 8 over minus 16, which is minus half. So that's the limit of the function as y tends to 0. I hope you enjoyed this.